You hear about these crazy, powerful AI models all the time, right? Things like GPT-3 that can write, create, and, well, it feels like they can almost reason. But what's actually going on under the hood? What's the engine that's making all of this happen? Well, in this explainer, we're going to break down the incredible technology that makes it all possible. We're talking about transformers.
Okay, ready for this? Why did the banana cross the road? Because it was sick of being mashed. Yeah, I know. It's not exactly a side splitter, right? You're not going to see that headlining a comedy special anytime soon. But here's the wild part. The thing that makes this joke really interesting. A computer wrote it. Yep, specifically, a model called a generative pre-trained transformer. You might know it as GPT-3.
And that just leads to the big question, doesn't it? How is that even possible? I mean, how can a machine get the whole structure of a joke, the setup, the punchline, and then just create something totally new on its own? Well, let's dive in and find out. All right, so to really get our heads around how this works, we're going to start with something a bit simpler, something we're all familiar with, language translation. Turns out, this is the core job that transformers were first built to do, and honestly, it's the perfect way to understand what's really going on. So what even is a transformer? Well, when you boil it all down, it's a deep learning model that's designed to do one main thing. Take one sequence of data, say a sentence in English, and transform it into another sequence, like that same sentence, but in French. That's why you'll hear people call it a sequence-to-sequence model. And this is a perfect example. See? You've got the input sequence on the left, our little banana joke, and the transformer's whole job is to spit out the output sequence on the right, which is the French translation. But here's the key. It's not just doing a simple word-for-word lookup. No way. It's actually understanding, grammar, context, and the right word order to build a whole new sentence that actually makes sense.
Okay, so how does the machine actually pull this off? Let's pop the hood and take a look at the two main parts of the engine here, something called the encoder and something called the decoder.
All right, I know this diagram looks a little intense at first, but don't worry. Let's just focus on the most important parts. See those two big stacks on the left? The encoder and the decoder? Just think of it like this. The English sentence goes into the encoder, which figures out what it means. Then, the decoder takes that meaning and uses it to build the new French sentence. And that's really it. The encoder understands, and the decoder generates.
So it's basically a two-step process. First, the encoder reads the entire sentence all at once. It creates this kind of mathematical summary of what it all means, figuring out which words are important to other words in the sentence. Then it just hands all that juicy context over to the decoder, and the decoder gets to work generating the new sentence. But get this, it does it one single word at a time until the job is done.
But here's the thing. Older models had encoders and decoders too. So what's the big deal? What makes a transformer so special? Well, this is where we get to the secret sauce, the one huge breakthrough that literally changed the game. It's all about something called the attention mechanism. Think about it like this. If you're in a noisy, crowded room and you're trying to listen to just one person, your brain doesn't just process every sound in order. No, it focuses. It pays more attention to that one person's voice and tunes out all the other chatter. Well, the attention mechanism does pretty much the same thing for a sentence. It looks at all the words at the same time and figures out which ones are the most important for understanding the meaning of every other word. It gives it a real, deep understanding of the context. And this is a really crucial difference. You see, older models, like what we call RNNs, had a huge bottleneck. They had to read a sentence one word at a time in a strict order. And if the sentence was really long, they could actually forget what the beginning of the sentence was about by the time they got to the end. Transformers? Totally different. They process all the words in parallel, all at once. That attention thing we just talked about lets them connect ideas from anywhere in the text, no matter how far apart they are. And being able to process everything in parallel like that, well, it's a huge deal. It means you can train these models on absolutely massive amounts of data, way, way faster than the old models. And that's what makes them so incredibly powerful and so good at understanding all the little subtleties of human language.
Okay, so we've got a handle on how they work. Now for the fun part. What can you actually do with this stuff? Let's move past just translation and look at some of the coolest and maybe even most surprising things these models are capable of.
First up, of course, is language translation. I mean, this is where it all started for transformers. They've pushed services like Google Translate to a whole new level, one where it feels almost seamless. It can understand idioms and tricky phrases in a way that just wasn't possible before. They're also amazing at summarizing documents. Think about it.
You can give a transformer a super long, dense article, and boom, it can spit out a short, accurate summary that hits all the main points. It's kind of like having a lightning-fast research assistant on call.
And this, of course, brings us right back to our banana joke. Transformers can create completely new stuff from scratch. We're talking blog posts, marketing copy, emails, and yeah, even cheesy dad jokes. That's the generative part in GPT. It generates new content.
But here's where it gets even crazier. It's not just about text. Some really smart people figured out you can treat the pixels in an image kind of like words in a sentence. And now transformers are being used for really complex image stuff, like creating a picture just from a text description or identifying objects with insane accuracy. They're even starting to rival models that were built only for computer vision.
And if that wasn't enough, get this. They can even learn to play chess. If you think about a game of chess as just a sequence of moves, well, that's exactly what a transformer is good at. It can learn super complex strategies and play at a seriously high level. It really just goes to show you how incredibly flexible this whole architecture is.
So there you have it. From bad banana jokes all the way to grandmaster-level chess, transformers are clearly a huge, foundational part of modern AI. But, understanding the tech itself, that's really just the first step on a much, much bigger journey.
This roadmap here kind of lays it all out. Getting the tech, understanding things like transformers, that's like your AI 101. But if you actually want to build things with this technology, you've got to master the whole process, from deep dives and prompt engineering all the way up to product strategy and design. There's a whole world to explore here.
So if you're ready to go from just understanding these models to actually building the next wave of amazing AI products, I really encourage you to keep learning. For some seriously deep insights into AI strategy and leadership, you should definitely check out the AI Product Management Playbook by Deepak Dio. We've put the link down in the description for you. Thanks so much for joining me.